If mitochondria were a problem in 2019, they're 10x that level of problem globally now. So it's a skill set you just have to learn. So now we talked about pyruvic acid, and we showed that in that diagram, you have to convert glucose into pyruvic acid, and then it goes into the citric acid cycle. So if pyruvic acid is high, it means that that enzyme, pyruvate dehydrogenase, isn't working properly. So you're not able to get glucose into the mitochondria. And this would be the very beginning of insulin resistance. Some patients may be insulin resistant if you see a high pyruvic acid. Some of them are just on their way there. They're not quite insulin resistant yet, but it's coming up. And so then you want to get that enzyme to work properly. In case you don't know, they show you which are the nutrients that you need to make that enzyme work properly. B1, B2, B3, B5, and lipoic acid. If you get enough of those B vitamins and lipoic acid, that enzyme's going to start to work again. And guess what? The pyruvate will go into the energy pathways and the person will feel better. And you're, in a sense, either preventing or reversing insulin resistance. And the enzymes can get damaged from oxidative stress. So we want to protect the enzymes. We want to get them working right, reduce the oxidative stress. That's the goal. And that will help push that person out of this stuck mitochondrial phase and into a phase where they can start to repair. So 8-OHDG, that shows, if that's high, it shows a high level of oxidative stress. So now we have enough to build our program just from those two factoids. First of all, we're gonna work with antioxidants, and there's two types generally. There's fat soluble and water soluble antioxidants. And this is kind of important because if you want to protect the membrane, remember the cell membrane, or if you want to protect the mitochondria itself, the membrane in the mitochondria, you want to focus on, not exclusively, but you want to include, let's say, fat soluble antioxidants that'll protect membranes because they're fat soluble and they'll go where the membranes are because the membranes are all fat. And then you can also independently, and pretty much always will also separately use water-soluble antioxidants like glutathione and vitamin C. But you want to use usually a combination of the two, fat-soluble and water-soluble, and they do slightly different things. They work in slightly different ways. Improve glucose metabolism, which obviously is going to help with energy. Reduce oxidative stress, which will obviously help with energy as well. And so we know from that report, you can see it printed right on the report, high pyruvic acid means we're going to use B1, B2, B3, B5, and lipoic acid. Usually that means using a B complex, say like twice a day, plus some additional lipoic acid. So here, check this out, pyruvate requires thiamine or B1 to kick things off, then lipoic acid, then the other B vitamins. So you can have a bottleneck right here with thiamine. You just give a person like 100 milligrams of thiamine once or twice a day, and boy, that'll change things pretty quickly, okay? Because that'll just get this whole thing moving, and then lipoic acid does the second step, and then boom, you finish it off over here. This is like a beginning one, but I put a question mark there. And then we want some antioxidants to reverse the oxidative stress. And so the easy ones that are, sort of used all the time, back to CoQ10, you could do 100 milligrams of that a couple times a day. And another super common one that's used would be N-acetylcysteine or NAC. Comes in a 900 milligram. You could use that. If you don't like NAC, you could use glutathione, but you want a couple of antioxidants to make all this work. And that would be an appropriate program based on that lab to get relief from the fatigue that's happening because the mitochondria aren't working.